All right, let's move on. Okay, now we don't always do this on this show, but every once in a while something interesting pops up and we all get out of our wheelhouse and talk about cool stuff. Now this is not my wheelhouse, but it is sort of my hobby wheelhouse because I like computers, tech. Yeah. I love tech. I build my own computers from scratch, which I love doing. So we are going to talk today about what is a quantum computer. Whoa, look at that thing.
It's
that
like
looks
an evil genius basement.
Definitely. That looks like it would be at Elon Musk's house.
Yeah.
Maybe like in his entryway. So, have you guys ever heard of a quantum computer?
Yeah.
Sarah?
Uh-huh.
Trey?
No, I have not.
You have not?
I've never heard of a quantum
Never heard of a
computer
quantum
before.
computer.
No,
Okay.
I have not.
So, this is going to be kind of a difficult segment to grasp, but my goal here is to educate you guys about quantum computers enough that if you're at a dinner party and someone says quantum computer, you can be like, oh, I know about that because I watched Nip Talk, and obviously that makes me a genius. And I know enough to talk about this in a way that I won't sound dumb. Now, the thing is quantum computers are extremely complex.
Does it have to do with AI?
Only in that quantum computing could be helpful for AI.
Okay.
Yeah. Okay. So this comes from, and the reason we're doing this is there was a recent announcement by Google. Throw up that pic, Trey, if you can. Trey's obviously busy in there. Trey, you there? There we go. He's getting distracted. I see why you're getting distracted, Trey. I'm watching you. All right. So Google this week announced that it's cracked a quantum computer challenge with a new chip. So quantum computers, which I'm about to talk about, are kind of new technology, and all IBM, Google are racing to be the world leaders in quantum computing. And this new chip called Willow solved a problem in 5 minutes that a normal traditional computer would take over 1 billion years to solve. All right, you see the application now?
What was the problem?
So it's basically a very, very complex math problem, okay? And I'll explain why that's important in a second. That's a great question. But a problem so complex a traditional computer could not solve it in 1 billion years was solved by Willow in 5 minutes. So what is a quantum computer? Throw up that pic I want to show. Yeah, so there it is. That's we're talking about the evil genius basement. So that is actually a quantum computer. Now, most of that is cooling for the processor, and I'll explain why that's important. So if you want to know what a quantum computer, you first have to have a basic understanding of how a traditional computer works, which I assume you guys probably don't know a lot about how a computer works. I mean, you just turn it on, right? I mean, that's a lot of like us. I mean, how does my cell phone work? I mean, I kind of have some idea, but how does a computer work? So let me break this down into very, very basic information that can be processed, okay? So information in a computer is processed in binary code. You guys heard of binary, ones and zeros?
Yes.
Yep, follow me so far? Trey? Yep, ones and zeros. Okay, so all a computer is doing is using microtransistors. A microtransistor is like a flashlight. It's either on or it's either off.
Okay.
If it's on, that's binary 1. If it's off, it's binary 0. Okay, follow me?
Yes.
Okay, so a computer is made up of billions of microtransistors that are either 1 or 0. And these ones and zeros are these bits, which is short for binary digit, are organized into sections called bytes. So a byte is 8 bits. You've heard of 8-bit technology. Then there was 16-bit technology. Currently, computers are using 64 bits. So that is a code of 64 ones and zeros, which then can be converted into information. Okay. So for example, when you hit an A on your computer, I think the binary for A is 001000001. Okay, that represents an A. All right, so if you understand that, then you can then understand how everything is assigned to binary code, and that's how a computer processes that information. All a computer is like 20 billion little flashlights that are on or off, and then algorithms determine what those flashlights being on or off mean. Okay. So like when you hit like a letter on your keyboard, there's little transistors that are on or off. The computer recognizes that, and then the operating system does stuff with that, and then it produces an output.
Yeah.
Does that kind of make sense? On and off, right? Trey, you follow me?
Yes.
I see that we're good. Okay. So that is how a computer works very basically, okay? So with the bits, they're either 0 or 1. Remember that?
Yes.
Okay, they're either on or off. In a quantum computer, they don't have bits. They have something called qubits. Qubits, qubits. Now, the thing about qubits that makes them different than bits is they can be 0, they can be 1, or they can be any number in between, all right?
Okay.
And also, so that's called superposition. That's a term you'll hear with quantum computers. Superposition means that the value can be 0 or 1 or anything in between, but also they can be entangled, which means one qubit controls another. Now, don't get lost in the weeds here, but just know that increase in variability of what a qubit can be means that a quantum computer can process an enormously more amount of information. And kind of the analogy that is used to show that is, say you have a maze that has a billion different ways to get out.
Okay.
Or a billion different pathways, but only one way to get out.
Okay.
A traditional computer will check each of those billions of different pathways to find the correct answer. It'll use one, it'll be wrong, it'll go to the next. It'll search another one, it'll go. So it's going to do that billions of times. A quantum computer can search every pathway simultaneously because of the increase in variability in the qubit over the bit.
Yeah.
And so what that means is that a quantum computer can determine information in a much bigger scale. They're not necessarily better for writing an email. They're not necessarily better for playing a video game.
They're better for processing.
They're better for processing enormously complex questions.
I feel like basic computers, the way it sounds like to me, is a basic computer has basic computer language, and then the quantum computer is just like a more elevated, smarter language.
Yeah, you're on the right track.
Right?
Yes, you are on the right track. Basically, a quantum computer is good for very specific things. So, for example, if you wanted to look at a molecule to determine what a drug would do, so like determining, like making new drugs, the variability in that molecule of each electron and proton spinning around is just insanely complex. A traditional computer could never model that.
Yeah.
There's too many different pathways that could happen, but a quantum computer can. And that's like one of the biggest potential applications, is that a quantum computer could help create drugs very, very quickly that a traditional computer would take years and years to map out.
Yeah.
The other thing is encryption. You know, all of the encryption of the internet and banking software and your passwords is done by something called RSA, which is looking at prime numbers and solving extremely complex questions. And the only way that RSA can be broken is if you know the answer. You know, the only way to know the answer is, or the only way to get the answer correct is if you know it. A computer would take billions of years to crack the code. A quantum computer can do it in minutes. And that's why quantum computing is so important, because whoever masters quantum computing is going to have an enormous advantage.
So it's not mastered yet.
No. So to break RSA encryption, you would have to have a quantum computer that had roughly 1 million qubits, okay? Remember, a modern computer in bits has like 20 billion, all right? So 1 million is way, way less than 20 billion, right? So 1 million qubits would not be a very complex quantum computer, potentially. The Willow, the one that broke this program, has 105 qubits.
Okay.
So we're not quite there yet. But like everything, the technology with quantum computers is increasing exponentially.
And it looks like a big machine.
Yeah, it looks like that thing.
It's like huge.
The one thing that makes quantum computers more difficult to actually build is that qubits are very, very sensitive and prone to errors by any outside interference, including temperature. Any type of heat molecule will disrupt these qubits and make them give wrong answers. And so a quantum computer has to be maintained near absolute zero, which is minus 459 degrees Fahrenheit. And that's why I can't just go build, I mean, I guess technically I could if I had unlimited supplies. I can't just go build a quantum computer like I can, because that's one of the big rate limits.
I'm sure eventually it'll be like as small to put in your hand, just like the first computers were like as big as like a convention center or whatever.
And now like we have computers like this,
in
which
your
are
hand.
more powerful than supercomputers of 20 years ago, and it's all in this.
Yeah.
Yeah, you're absolutely right. Technology is advancing.
And it'll be like, it's like, because I was doing research for my master's degree about AI, and they do drug-to-drug interaction.
Yeah, so
things.
quantum computing would be right up your alley with what you guys do at American Heart Association.
Yeah.
Yeah, absolutely. So, so But the main take home, like, so if you're going to talk about quantum computers, like, really, if you want to get anything out of this, is that quantum computers use qubits as opposed to bits. And in a traditional computer, a bit is a 0 or 1, and a quantum computer, that value can be 0, 1, or anything in between. And that extra variability allows for insanely increased computing power, with the best analogy being about the maze. So, all right, I think that's about all the time we have for this episode. Thank you guys so much for tuning in. We really do appreciate it. Please leave us a comment if you want us to talk about any topics. We would love to hear from you, and we'll see you on the next episode of Nip Talk.
Bye.
Bye.